The Biosis model has a number of advantages over other models that have been used for the same purpose internationally. Our model takes account of the entire turbine, not only the moving rotors, but also the tower and the nacelle, and allows for the potential for a bird to fly into the turbine and be struck or strike the turbine. And whilst it's not usual for birds to fly into stationary objects like the tower, it does happen occasionally, and there are occasional records of that. Another aspect, other models tend to assume that every bird flight is directly into the face-on to the moving rotor and the blades. Obviously that's not the case. In real life, birds can fly towards a turbine from any direction, and so the Biosis model was built to allow for that by allowing birds to fly from any direction. It takes a mean area of a turbine as a bird might approach it from any direction, and in that way it also means that the model isn't reliant on the particular height of the bird within that rotor swept zone, and the bird can fly towards it from any direction. The third one, which is a really important one, is that the difference between the number of flights and the number of individual birds making the flights. And I can perhaps explain that best by saying that if we collect data for birds flying around at a wind farm site, at the one extreme we might have a flock of 5,000 birds fly through the site once in a year, and theoretically it's possible, therefore, that the number of birds that could collide are the entire flock of 5,000. That's not likely to happen in reality, obviously, but that's theoretically possible. But that's rather different from the situation where a pair of birds, say a pair of eagles, live at that site, and there are only two of them. During the course of the year they might make 5,000 flights, but clearly you can't kill 5,000 eagles, you can only kill the number of birds that actually reside there. So that's an important part, and other models haven't made the distinction between the number of flights and the number of individuals, and it actually caps the number of potential collisions at the number of birds involved.